Hello, and welcome to this lesson on applying an Avogadro's law to calculate volumes of gases involved in a gaseous reaction. In today's lesson, firstly, we will review how we apply Avogadro's law. Then, our lesson objective for today is to learn how to calculate the volumes of gases involved in a reaction by using the relevant chemical equation. So far, we've explored Avogadro's law, which states that equal volumes of gases at the same temperature and pressure contain an equal number of molecules. You've also gained experience using Avogadro's law to determine the volume of a gas. Building on this foundation, today's lesson will enhance our chemical understanding by more complex examples of calculating volumes of gases in reactions. This will deepen our insights into the relationships between gases and chemical equations, allowing us to predict and quantify the outcomes of gaseous reactions more precisely. Let us start by recapping Avogadro's law and seeing how we can use it to solve problems involving gas volumes. Firstly, Avogadro's law states that equal volumes of gases at the same temperature and pressure contain equal numbers of molecules or moles. This law gives us a direct relationship between the volume of a gas and the number of moles of that gas. Doubling the number of moles at the same temperature and pressure doubles the volume. Similarly, halving the number of moles at the same temperature and pressure halves the volume. How can we use Avogadro's law in practice? Let's look at a gaseous reaction and see how this law can help us calculate volumes of gases involved. Suppose we look at the Haber process. N2 plus 3. H2 produces 2 NH3. In this equation, 1 mole of nitrogen gas, N2, reacts with 3 moles of hydrogen gas, H2, to produce 2 moles of ammonia gas, NH3. According to Avogadro's law, the volumes of these gases will be in the same ratio as their moles, as long as the temperature and pressure are constant. For instance, every unit of volume of N2 gas reacts with 3 units of volume of H2 gas to yield 2 units of volume of NH3 gas. This is because the volume of gas directly relates to the number of moles of gas in it under constant conditions. Suppose we have 5 liters of nitrogen gas, N2, and we want to know how many liters of hydrogen gas, H2, are needed, and how many liters of ammonia gas, NH3, will be produced. Using Avogadro's law and the stoichiometry of the reaction, the equation shows that 1 mole of N2 reacts with 3 moles of H2. Due to Avogadro's law, this means that 1 unit volume of N2 reacts with 3 unit volumes of H2. 1 liter of N2 would react with 3 liters of H2, therefore, 5 liters of N2 will react with 15 liters of H2. The equation also shows that 1 mole of N2 produces 2 moles of NH3. Due to Avogadro's law, this means 1 unit volume of N2 produces 2 unit volumes of NH3. Since 1 liter of N2 produces 2 liters of NH3, 5 liters of N2 will produce 10 liters of NH3. To summarize, Avogadro's law allows us to calculate the volumes of gases involved in a reaction by simply using the molar ratios from the balanced chemical equation. By knowing the volume of one gas, we can determine the volumes of the other gases involved in the reaction, as long as the temperature and pressure are kept constant. This concept is especially useful in industry and laboratory settings where precise measurements of gases are necessary. Learning to apply Avogadro's law can greatly enhance your ability to predict and control the outcomes of chemical reactions involving gases. Let's do some further practice to consolidate our new knowledge. Let's start with example 1, which is simple stoichiometry with gases. In the reaction 2H2 plus O2 produces 2H2O. If you start with 5 decimeters cubed of H2, what volume of O2 is required? And what volume of H2O will be produced? According to the balanced equation, 2 moles of H2 react with 1 mole of O2 to produce 2 moles of H2O. By Avogadro's law, this means that every 2 units of volume of H2 react with 1 unit of volume of O2 to produce 2 units of volume of H2O. So if we start with 5 decimeters cubed of H2, since the ratio of H2 to O2 is 2 to 1, the volume of O2 would be half of H2. So the volume of O2 is 2.5 decimeters cubed. And since the ratio of H2 to H2O is 2 to 2, the volume of H2O produced is the same as the volume of H2. So 5 decimeters cubed of H2O is produced. Now let's try example 2. In the reaction N2 plus 3, H2 produces 2 NH3. If 10 centimeters cubed of H2 is used, what volume of N2 is required, and what volume of NH3 will be produced? According to the balanced equation, 1 mole of N2 reacts with 3 moles of H2 to produce 2 moles of NH3. By Avogadro's law, this indicates that every 1 unit of volume of N2 reacts with 3 units of volume of H2 to produce 2 units of volume of NH3. If we start with 10 centimeters cubed of H2, since the ratio of H2 to N2 is 3 to 1, the volume of N2 would be 1/3 of the volume of H2, so 3.33 centimeters cubed of N2 is required. And since the ratio of H2 to NH3 is 3 to 2, the volume of NH3 produced is 2/3 of the volume of H2, so 6.67 centimeters cubed of NH3 is produced. Finally, let's try example 3, combining volumes in a series of reactions. Consider the following series of reactions. Firstly, reaction A occurs followed by reaction B. If you start with 8 decimeters cubed of NO2, what volume of CO2 is produced? In reaction B, the NO3 produced in reaction A reacts with CO to form CO2. This means that in order to find the volume of CO2, we must first find the volume of NO3 produced. According to the balanced equation of reaction A, 2 moles of NO2 produce 1 mole of NO3. This indicates that 2 units of volume of NO2 produce 1 unit of volume of NO3. The ratio of NO2 to NO3 is 2 to 1. Hence, the volume of NO3 produced is 1/2 the volume of NO2, so 4 decimeters cubed of NO3 is produced. According to the balanced equation of reaction B, 1 mole of NO3 produces 1 mole of CO2. So, every unit of volume of NO3 produces 1 unit of volume of CO2. The ratio of NO3 to CO2 is 1 to 1. Hence, the volume of CO2 produced is the same as the volume of the NO3, which is 4 decimeters cubed. So, using 8 decimeters cubed of, NO2 produces 4 decimeters cubed of CO2. By following these steps and using Avogadro's law, you can calculate the volumes of gases involved in various reactions. In today's lesson, we delved into the application of Avogadro's law to calculate the volumes of gases involved in a gaseous reaction. We began by recapping Avogadro's law, which states that equal volumes of gases at the same temperature and pressure contain an equal number of molecules. We then applied this law to various gaseous reactions where we practiced using ratios to calculate the volume of gases produced or consumed in a reaction, given the volume of another gas involved. Through this lesson, we've gained a practical understanding of how to use Avogadro's law in quantitative chemistry. This knowledge will be essential as we continue to explore more complex chemical equations and reactions in future lessons.